Okay, so with this video, just some basic modeling techniques, and in particular, we're going to take a look here at linear regression, OLS, and we have an example that we've already developed in Excel. So we've basic data student-teacher ratio to test scores. Now, this is already the OLS output has already been set up in Excel and already explained a little bit in the RStudio environment, and we can make the two tally together. And I've taken this code originally from econometrics with R, so you can follow the link. Now, this snippet of code I've put into Google Colab. We can just take a quick run through. We can, if we run, again, a little bit of explanation. If you're running R in Google Colab, you need to load in this line of code. We're going to manually enter the data, and we're going to print out student-teacher ratio 15, 17, 19. We only have 7 observations, and then test score something similar. If we were to graph, then plot the test score against the student-teacher ratio, we kind of see a negative relationship. Maybe this one's a little bit out. But seems to be, broadly speaking, a negative relationship. When we set up the model, this is a linear regression. So we are regressing test score, the dependent variable on student-teacher ratio. And then when we print out the coefficients here, we just get basic output. If I want more output, I would say summary of the linear model. Remember, the linear model is stored here in this object, and when we print out, say, summary linear model, we're using base R just to say, look, okay, report back the output. So this is more complete. The coefficients are reported here, the standard errors, the t-values, and the p-ratio. Now, what we observe here is the t-value is not that high. It's less than 2, and the p-value is greater than 0.05. So we have questions about the statistical significance. Really, this is just because we have so few data observations, right? It's hard to be 100% sure with so little data that we do have a negative relationship. Okay, to get a summary of the coefficients again, if we just wanted the coefficients in the model, again, we've that output, again, the same numbers. To print out the residuals, we just say residuals of the linear model. To get the degrees of freedom, it's 7 minus 2, so that gives us 5 degrees of freedom. And here we're looking, we are trying to construct a boundary with confidence interval around the estimate for the coefficient on the student-teacher ratio. We might note here we cross 0. So within the confidence interval, the 95% confidence interval, we cross from -8 to +2. So 0 is a real possibility. And we can't really say if the relationship then is categorically positive or negative. Again, the boundary here is the -8 to +2, the lower and upper confidence interval, given the 2.5 and the 97.5 distribution percentiles. Okay, so there's a summary of all the data there, at all the code there, and that's just an implementation in Google Colab, quite handy. And you may make use of linear regression OLS commands in Google Colab, so very practical.